Good morning, good afternoon, and good evening. We are so glad that you're here and decided to join us for another great day of learning and inspiration. Today's session is MicroStation for the transportation industry. So without further delay, now you are going to hear from Eduardo Cortez and Marina Savankova on how MicroStation plays a vital part of the project workflow for transportation and civil projects. Eduardo and Marina, take it away.
Thank you, Molly, for introducing Marina and I and presenting the session. The next 30-40 minutes, we will spend exploring three main topics that we want to highlight, right? It's about why to use MicroStation for transportation industry. So analyzing this topic about why to use it, we want to do it analyzing some global case study where our users were using MicroStation in this transportation project, and also together with the project or the user case analysis, we will show some examples about how MicroStation is providing these capabilities to empowering the project, right? So the first question I told you is about why MicroStation for transportation industry. And in order to do that, we try to remember what is MicroStation, right? Or why to use MicroStation. MicroStation is not only a CAD software. It's a CAD software, but at the same time, it's a comprehensive solution that empowers any design project, right? MicroStation is usually used by the software professional to design, to model, and to manage infrastructure data. Remember that MicroStation is the CAD created for infrastructure project, right? So we are giving the user a tool that is enable them to consolidate critical project data in a single environment with a single file format, and also helping to secure, create secure project deliverable, right? And also MicroStation is designed to accommodate projects of all sizes, from the smallest to the large scale infrastructure project, and also that cover short or long life cycle, right? And it's important to remember that MicroStation, a part of the Bentley's CAD product, is the foundation, is the technology that supports the entire Bentley modeling ecosystem, right? And with why to use MicroStation, we put the focus on the three key capabilities we understand that are provided by MicroStation. The first capability, we call it model anything anywhere, right? That this is meaning that MicroStation has the capacity to design anything you can imagine, but at the same time, we always provide the solution, the tools to do it, linked to the context, right? It's very important to remember that you cannot design an infrastructure project disconnected from the context. So this is why the anywhere is very important for us, right? Apart from that, we speak about MicroStation is a tool that can read and consolidate anything. This is important because you can collect data from different sources, collect data from different file formats to create the global final picture of your project, right? And also, when you consolidate everything, you start with the ecosystem, with the model ready to start reporting and informing people, right? Reporting everything, because it's not only data created by MicroStation, it's also the data created with other tools, acquiring external data, and also informing everyone, because it's not only production report, it's also that MicroStation is the door, or MicroStation is the tool that with this aggregate model can be upload, can be feed the digital twin stored in our iTwin services, right? So we can later share the link with other team members or other stakeholders. Now I would like to pass the opportunity to Marina to speak, and Marina will give us more information about some of the user cases. So up to you, Marina.
Thank you, Eduardo and Molly. We start with the first case. It's a project, the per Genova Viaduct from the Italfer SPA, Genoa, Italy. After a bridge collapse in northern Italy, Italfer SPA was tasked with designing a new viaduct. The structure would be a pivotal point for not only the city and country's transportation, but a part of key roadway that links Italy and France and is the main access point to nearby airport. Intel Fair SPA implemented a BIM model along with Bentley's connected data environment based on ProjectWise. The project team used MicroStation and Bentley's civil applications to create digital models of the terrain, roads, civil works, and mechanical and electrical system. The next video will show us some tools, MicroStation tools that can help us to work with transportation area. This is a perfect example of using MicroStation tools. As a fast-paced world, flexibility and adaptability are critical. Transportation engineering often involves designing complex structures, and having the right tools is essential. MicroStation provides engineers with the ability to model anything, anywhere. With its parametric design capabilities, engineers can create parametric 3D libraries that are not only visually applies but also highlight functional. This example shows us how we can modify the tunnel element with MicroStation solid tools. So if we use solid tools to create some tunnel element or other transportation element, we can use modify tools to modify it.
Thank you, Marina, for your explanation about the modeling capabilities. In the next case we are going to review is the new test track for autonomous and electric vehicles by A3i in Sweden. Right? A3i was selected by the commercial vehicle manufacturer Scania, probably you know, to design a new test track where they want to test and drive electric and autonomous technology for heavy vehicles. The test track was included 19 kilometers of road with more than 60 intersections and junctions. The most interesting thing here is A3i used the applications to produce accurate 3D models, but the models were enriched with product data as well as to verify the impact of design on the environment. So the most important thing here is about using MicroStation to verify the impact of the design on the environment and to verify the impact of the environment on the design, due the capability to design in context, right? So what we want to show now here is how important is design in context. In this example, you can see a geo-coordinated model that is showing the aerial BIM maps of our region. This is the region in Italy, in Pescara. And we can see how we can attach the high-quality reality mesh of the Pescara city. We can also go into the level display tool. We can switch on and off different elements. And at the end, what we can do is combine the city mesh on top of the aerial maps. And also we are adding or identifying or switching on the DGN file. Right? So on top of the mesh, what you can see is that there are a lot of DGNs showing the road, the 3D model of the houses. That is mainly what is compelling, what is included into a city. Right? So combining reality meshes with 3D model is a very useful methodology to work in urban planning or to work, as we spoke before, linked to the context and remembering how important it is to design linked to the existing context, right? And this is another example is from the new workflow that is called geospatial context, right? In MicroStation 2023, we added a new workflow called geospatial context where you can have all the option to use the BIM maps, coordinate system, and also Esri GIS services. And this example, you can see how we can combine the BIM maps with information coming from Esri services regarding the streets or the roads planner, right? Or the path planner. So at the end, what we are trying to do is elevating the concept of a CAD tool, including the capabilities to ensure that your project is aligned with the existing context. Now I will pass again to Marina, who will explain the next user case.
Thank you, Eduardo. And here we have next case. It's transit-oriented development Dubai from the company WS Atkins and Partners Overseas, Dubai, United Arab Emirates. W.S. Atkins and partners overseas had to be innovative when designing an underground rail station for Dubai's green and red metro lines near an existing shopping mall. We were looking for sufficient application for integrating the project with the surrounding buildings and effectively delivering their BIM vision. They deployed Bentley software. W.S. Atkins overcome site constraints with MicroStation parametric modeling capabilities. MicroStation powerful constraints capabilities usable in both drawing and modeling workflows enabled them to maintain design intent while rapidly moving through design iterations and progressing development. We solved the station's complex interface geometry within the application, eliminating one-site measuring. Next video will show us these tools in action. In this video show us how we use last version of MicroStation to create rail track parametric cell. In this example, we use prepared 2D shapes of sleepers, rails, holders, and bolts. Moreover, when we work with the parametric cell, we can create parametric shapes if we know that there is requirement to change them during the using our parametric elements. In our example, we don't need so detailed example of rail track. We use it modify solid tools to subtract one solid from another. And it shows us how we can model complicated shape of solid elements. We use it tools extrude and extrude along to create holders and the bolts. We used constraints tools to add fixed points to our solids and attach our variables through 3D dimensions. During the creating our element, we can check if our variables works. We multiplied sleepers with the holding elements by solid array tools. And in the end, we can check that the length of sleepers and rails are changed by our variables. Then we can use our MicroStation parametric cell in other civil application. So we use library of cell element, we place it our element, change variables. And next example will describe Eduardo.
Thank you, Marina, for the good explanation. The next case we are going to review is the Hong Kong boundary crossing facilities. This is a project in Hong Kong by the Leighton Chung Guo joint venture. This project includes the creation of pile foundation, reinforced concrete structure, profile steel roof, curtain walls, and glazing to create the Hong Kong Zhuhai Macau Bridge. That is a 50 kilometers link that comprises a series of bridges and tunnels that connect the three cities, right? So in this case, the user uses MicroStation and Open Roads to create a common platform to collaborate on all structures and to manage all the project information. As we spoke, they were using MicroStation here to consolidate data from different sources, right? The next example is about the bridge over the Llobregat River. This is a user in Spain, Comsa. They were using MicroStation together with Open Roads and Open Building, as you can see there. The project is a 2.4 million euro project that involved the renovating a century-old bridge over the river, the Llobregat River, and the access road in Cabrian, Barcelona. So the project, in this case, concentrated MicroStation, Open Roads, and Open Building, because the three tools are sharing the same DGM file format, so it's interesting or it's helping to establish a collaborative 3D modeling environment, and also helping to integrate data like the geological and structural elements and link them. So they were producing an integrated BIM model, integrated model full of data for communicating and for producing all the data from the project, right? And we have here a third project that is from Israel, the Jerusalem Light Rail Transit Network, where the user were asked to make extension of the Jerusalem Light Rail Network, as I was speaking before. The new station was adding 17.2 kilometers of track to the existing rail line between the new Yaakov neighborhood in the northeast of the city and Ein Karen in the southwest of Jerusalem, right? The project was 2.2 billion of British pound. So, but the issue is the project here was mandating that all the design should be submitted in DVG. So what they did is they used OpenRail to design the complete project, and they used MicroStation to take all the data created in OpenRail and produce massively all the DWG files, right? So they were accommodating the conversion of the DGN to DVG without losing information before to submit it, right? So we were speaking about 3 cases of data integration and interoperability, mainly about integrating data from MicroStation from other sources, right? So as an example of that, we are having here an example of MicroStation collecting data from a rail project, right? The rail project is combined by the station, but also the rail line. We need to incorporate the cartography, the terrain, the road access, or the bridge that is bringing the data, right? So it's not about modeling with MicroStation, as we were speaking before. It was about integrating data, the data with the reality measure, the cartography, because, as we were speaking before, it's so important in a project to put all the data together to, in the same file or in the same environment, but also linking with the context. So it's very hard to make a rail line or a station. You don't understand what is the existing context, or you cannot understand how are you affected to the existing context, right? And finally, having all this data together is not only about watching all the elements on top of the reality. It's also about the ability you can have to make a cut in the global model and include in this cut a section of the project showing the data from the building, this cad-station, data from the rail line, data from the terrain, and create combined output or combined data production to communicate the project, right? Now you can see this project. After this explanation, I think it's good time to pass on again to Marina for the next user case.
Thank you, Edo. This case is I-90, Snoqualmie Pass East from the company Washington State Department of Transportation, next short WSDOT. And WSDOT initiated a USD 551 million project to improve the 50-mile section of I-90 in Washington State. There increasing traffic and avalanche control closures have caused congestion. We are adding one lane in each direction, relining the roadway, stabilizing major rock cuts, constructing avalanche bridges, and making other improvements to meet safety and growing capacity requirements. In addition to designing the road improvement, WSDOT needs to visually communicate the environmental impact of the project to decision makers and the public. MicroStation ability to render animation using multiple computers gently reduces the total rendering time. On one workstation, each frame would have taken about 7 minutes for a total of 42 days per rendering pass. Using 40 units server render farm, the job took 3 days per pass. As a result, MicroStation process controller for distributed rendering saved 35 days in the rendering time. And in our case is Bristol area signaling renewal enhancement from the company Network Rail Walls and Western Region Bristol, UK. Network Rail Walls and Western Region had to install new signaling apparatus at Bristol Temple Meads station. However, evaluating and designing new track signals is expensive and difficult to coordinate. We realized that to showcase all the necessary renewals and predict the impact of the new signaling, we would need software to support an intelligent 3D model. Network Rail chose MicroStation as their CAD platform and used OpenRay design to recreate track geometry and place new signals before developing fly-through animation that allowed designers to view the project from the train driver's perspective. And this video will show us how MicroStation works with visualization. MicroStation contains tools for visualization and rendering photos. For visualization, engineers can use LumenRT. You can find them on the visualization workflow. This tool perfectly works with different size models. When you converted your DGN file to LumenRT, you can use local tools to animate your visualization and record the video. This video shows us several different projects that were produced by MicroStation and LumenRT. Here we can see the example of subway station, another example of railways bridge, some other railways, and the road projects. These elements, like cars, were placed by LumenRT. And next case will describe Eduardo.
Thank you, Marina, for the explanation. The final block we are going to review includes a couple of user cases. The first one is about the modernization of the Pardubice railway junction. This was done by the company Sudop Praha in Czech Republic. They were tasked modernizing the railway junction in the East Bohemia part of the Czech Republic, right? But due to the complexity of the surrounding environments, the project required a set of big workflows and the use of 3D modeling to ensure that the design was accurate and how to share properly and send properly our construction information. So in this case, the design team used MicroStation to create and regularly update AI models to inform the contractor so that they were having a clear understanding of all the activities that were occurring on site, right? And as you can see, they were using for the modeling OpenRail again, but they were using MicroStation to make the process of update to item, right? The final case we are going to check here is in Indonesia. Is the example of the integrated high-speed rail and station. This is done by the company PT Vijaya Karya. This is an Indonesian company, and the project was in Bandung. So in this case, the project was designed to reduce the congestion between the two cities, that this is between Jakarta and Bandung, and also fostering a culture of public transportation in Indonesia to solve this traffic problem, right? So in this case, the design team was using open civil design from Bentley, that is in this case OpenRail, and they were also using relative model application and to connect with the existing context, and later they were asked to create a tool, an ecosystem to facilitate the generation of a digital twin. So in this case, they were using MicroStation, collecting the data, creating the single source of truth to facilitate the dynamic modeling and also the generation of the intelligent file that were feeding to the digital twin, right? So these both cases are examples of how during the design they were doing, or they were following all the complete process, thinking on the creation of a digital twin. Now we can see an example, a real example, a big interesting example about both physical and digital models. So Crossrail was working with Bentley, as we spoke, with civil tools and also with MicroStation to collect data. This is the final result of what they create after the project was finished. That this is the physical model they were creating at the same time check it with the digital one, right? So creating a digital twin in the case of infrastructure project is key in order to not only for the phase of design, also for future simulation, future maintenance, and for the construction simulation. So if you need to do anything on the model, you can collect MicroStation, you can collect feeding the iTwin, and also you can see that the digital twin is always updated with the latest change, and also when the physical model needs to report any issue to the model, and the designers update the model automatically. Digital is twin is always synchronized, right?
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.